In this class, we explain how to test hypothesis for one population standard deviation. That is, hypothesis test for a population standard deviation. To explain hypothesis tests for a population standard deviation, we start with an example. Scenical capsules are used to treat obesity, and a standard prescription of Scenical is given in 120 mg capsules. That is the standard size of or weight of a Scenical capsule. But although the weight of the capsule vary from one another slightly, keeping this variation under a certain limit is important for medical reasons. And the acceptable variation, standard deviation, for Scenical capsule is less than 2 mg. A standard deviation less than 2 mg is the acceptable variation. So we have to test statistically whether this condition is satisfied in the case of Scenical capsules. To formulate this problem statistically, our null hypothesis is H0, sigma is equal to 2 mg, and H1, sigma is less than 2 mg. Sigma 2 mg, H1 sigma is less than 2 mg. Now, if this null hypothesis is rejected, the variation of weight of Scenical capsules is within acceptable limits. Now, the question is how to perform the test, how to test this hypothesis. Now, the steps are: take randomly n number of capsules. Then calculate the standard deviation of weights, the weights of the capsules. If S is too much smaller than 2, if S is less than 2, then reject H0. Now, suppose that 10 Scenical capsules are randomly taken. 10 Scenical capsules are randomly taken, and applying the formula for standard deviation, the standard deviation obtained is 1.055. The data will be considered by softwares. Anyway, now the question is, S is much lower than 2, but we do not know whether this is due to sampling error or whether this is statistically significant. So, in order to test this using this, we have to first specify the sampling distribution of the standard deviation. We have to first describe the sampling distribution of the sample standard deviation. Remember this, to test a hypothesis like this, mu is equal to a specific value mu 0, mu is equal to a specific value mu 0, we have to find out the sampling distribution of x bar. And in the context, it was assumed that x bar is normally distributed with the same mean mu and variance of sigma square by n. And so that t was equal to x bar minus mu 0 by s by root n. This t was used for hypothesis testing. Under the null hypothesis that mu is equal to mu 0, the test statistics on the assumption that population standard deviation is unknown, the t distribution, the t test statistics. Similarly, to test a hypothesis that h0, sigma is equal to a particular value sigma. As an example 2 here, sigma is equal to sigma 0 for a standard deviation equal to sigma of a normally distributed variable. Remember this, we have to test the standard deviation, population standard deviation. We use the sample standard deviation. But just as x bar is not directly used to test the population parameter mu, s is not directly used to test the population standard deviation sigma. What we use is a test statistics which is written as chi square is equal to n minus 1 into s square by sigma square 0. The test statistics is n minus 1 into s square by sigma square 0. So, this variable has chi-square distribution with n minus 1 degrees of freedom. So, to test this hypothesis, we use the test statistics chi-square as equal to n minus 1 into s square by sigma 0 square. It has n minus 1 degrees of freedom. So, in the form of a definition, suppose that a variable of a population is normally distributed with the standard deviation sigma. A variable of a population is normally distributed with the standard deviation sigma. Then, for samples of size n, the variable chi-square n minus 1 into s square, n minus 1 by 1 into s square by sigma square follows chi-square with n minus 1 degrees of freedom. N minus 1 into s square by sigma square has chi-square distribution with n minus 1 degrees of freedom. Now, in the example of conical capsules, what is chi-square? N minus 1 into s square by sigma square is n minus 1 into s square by sigma square is equal to 9 into s square by what is sigma square 2 square for chi-square with n minus 1 degrees of freedom. So, we use the test statistics chi-square as n minus 1 into s square by sigma square to test the hypothesis that sigma is equal to 2 versus sigma is less than 2. Now, so to test a population standard deviation H0, our null hypothesis H0 sigma is equal to sigma 0. The test statistics is chi square is equal to n minus 1 into s square by sigma square 0, and we call this the test statistics, and we call the testing procedure one standard deviation chi-square test. One standard deviation chi-square test, and this is the procedure. Now remember this, unlike Z and T tests, which we have discussed earlier, chi-square test is not robust to even moderate violations of normality assumption. So before implementing this test, it is absolutely essential to ensure that the variable under consideration is normally distributed. Otherwise, this testing procedure should not be adopted. Now let me conclude the procedure. This testing procedure is based on two assumptions. Assumption number 1, simple random sample, normal population. Then let me explain what are the steps. The first step is H0, sigma is equal to sigma 0, H1, sigma is not equal to sigma 0, sigma greater than sigma 0, sigma less than sigma 0. Second step is determine the value of alpha. Third step is compute the value of chi-square is equal to n minus 1 into s square by sigma square 0 with the degrees of freedom n minus 1. Then the critical values are given as chi-square, chi-square 1 minus alpha by 2, chi-square alpha by 2, chi-square alpha by 2, chi-square 1 minus alpha and chi-square alpha, the critical values for a two-tailed test, for a left-tailed test and a right-tailed test. And we take the decision on the basis of whether the value of the test statistics is in the critical region or in the acceptance region. If the value is in the critical region, reject H0. And in our example of scenical capsules, n is equal to 10, alpha is equal to 0.05, suppose. H0, sigma is equal to 2 versus H1, sigma is less than 2. Chi-square is n minus 1 into s square by sigma square is equal to 10 minus 1 into 10 into s square is divided by 2 square into 1.113 is equal to 2.504. Now for n is equal to 10 and for degrees of freedom is equal to 9 and chi-square 1 minus alpha, chi-square 1 minus alpha is equal to chi-square 1 minus 0.95 is equal to So chi-square 0.5 is equal to chi-square 0.95 is equal to 3.325. So the critical value is 3.325. 3.325. The sample value is 2.050. So you will get it as this is 3.325. What is obtained from the sample is 2.504. H0 is rejected. That means the standard deviation is within acceptable limits. Within acceptable limits. Or if you calculate the p-value of this 2.045, it is 0.0193. 0.0193, and that is it. So this is how we conduct hypothesis test for one population standard deviation. One population standard deviation. You can experiment with the different examples.